All right, in this last problem here, I wanted to try something just a little bit trickier. You'll notice that in this rational function, we do have an x squared term in the numerator and an x in the denominator. You should recall that if the exponent of the top is greater than the exponent of the bottom, that does mean that we will have a slant asymptote, or at least that if that degree is 1 larger than the one of the bottom. So we'll go ahead and jump right in, and we'll just start off easy finding the x and y intercepts again. So to find the x-intercepts again, set this function equal to 0, which is the same as setting the top equal to 0. And we'll just go ahead and factor that, and we'll get x minus 5 times x plus 4 is equal to 0. So then we get x equals negative 4 and x equals 5. If you watched my last video, you might have noticed that we didn't find any of the y-intercepts. Of course, that was because we got x equals 0 as an x-intercept, so that automatically gave us the y-intercept as well. In this problem here, though, that won't necessarily be the case. So to get the y-intercept, remember, just plug in 0 for x. So here we're finding the y-intercept, and we'd get 0 squared minus 0 minus 20 divided by 0 plus 2. Now, if you do that simplification, we would get y is equal to negative 10. All the way down here. Okay, so that's the x and the y-intercepts. Those will be helpful for us. Then we can go ahead and find, first we'll find the vertical asymptote. That's really easy. We just set the denominator equal to 0, no factoring needed. We get x is equal to negative 2. There's negative 2 right there, and there's our vertical asymptote. Now, like I said, we're going to get a slant asymptote. I'll go ahead and abbreviate that SLASY. Give me a second, I'm going to scroll down here a little bit. And to find that slant asymptote, we have to do something a little bit more complicated, if you recall that long division. So we're just going to take x squared minus x minus 20 and divide that by the denominator x plus 2. Now, to figure out this first value here, we have to just think about how many times that x goes into x squared. We don't really worry about the 2 until later. So x times x is equal to x squared, so it will go into it x times. Then we have to subtract off whatever x times x plus 2 is. So x times x plus 2 is x squared plus 2x. But remember, we're subtracting that. So x squared minus x squared is 0. And be careful here, it's not plus 2x because we have the negative out front, and that would distribute. So we get negative x minus 2x, which would be minus 3x. And then go ahead and bring down that negative 20 as well. Okay, now then we have to figure out how many times this x goes into this negative 3x. And that would be negative 3 times. And we'll just go ahead and stop the process of the long division here because we've already got what that slant asymptote would be, and it would be y is equal to x minus 3. Okay, going back up to our graph now, we can go ahead and put this in. Say this is negative 3 right here. Then our slant asymptote is going to look a little something like this. All right. If you did watch the last video, we talked about just using some test points to figure out which region, which part of this grid our function would be in, whether it's like that or whether it's like that. Of course, In this problem, we've already used some test points, right? We figured out all those x and y intercepts already. So it's easy for us. We know that to the right of x equals -2, we'd be using this region. Sorry, I kind of missed the x-intercept there, but you get the point. And then to the left of x equals -2, we already have that test point -4 there, and we're just going to follow those asymptotes again, and that's going to look something like that. Okay, and that's all there is to it. If you do have any questions, please feel free to leave a question in the comments below or send me a message in Ivy Learn.